All right, looks like we are live. Hello, everybody. My name is Scott, aka OX Protocon from Eigen Labs. I run protocol and developer relations here. I am with Jake, Noah, and Reece from Layer. And today we are going to discuss their main announcement. It's actually very exciting. I'm going to pull it up here. Waves, which is the base layer for building verifiable applications on top of EigenLayer, is going open source. That's going to allow everybody to see all the amazing things that they have done underneath the hood, fully understand it, extend it, fork it, all the good stuff that comes with OSS. So we have Jake and his team here today to talk about that. We're going to do some quick intros. I have a few high-level questions. Then we're going to dig into it. I saw these guys, especially Jake at ETH Denver, was super impressed with the demo. Even, I don't know how long ago was that, 7 months ago now?
It's a really long time ago.
Yeah, it was a long time ago. So I'm sure there's a lot to catch up on there. We'll dig into it. We'll run for, I don't know, 30, 40, 50 minutes maybe take some questions, and then clap there at the end. So with that, I'll hand it over to Jake and the team to do some quick intros, and then we'll get cooking.
Cool. I love intros. I'm Jake. I found out about Bitcoin in 2010 from post on Reddit. I've been through the entire crypto journey, and I made some things, like almost did an ICO in 2016, but then didn't. Well, we're gonna do an ICO now. It's great. Now it's a great time to do an ICO. But wait, I didn't mean to say that. We launched some Cosmos chains back in the day. A lot of us are Cosmos people. Not anymore. Now we're Ethereum people, because Ethereum's great. Actually, they've always loved Ethereum. I'm obsessed with DAOs. I'm really obsessed. Like, one of the things that makes me most excited about verifiable services is being able to build next-gen governance applications. And maybe we'll even talk about a few of them during this call. But yeah, that's me.
Awesome. Thanks, Jake.
I'm Reece. I'm the CTO at Layer. I've been working on Layer for about a year now. My main focus has been the product side and the development of getting Waves to market and making sure that it's a good user experience with things like our template, our documentation, working with the team on things like that, as well as continuing through and allowing us to do working on multi-chain applications and what does that look like from that point of view, as well as allowing for multiple different languages to be used to really amplify the use of things like WASM within the whole Waves runtime. And so making sure that we do things like that, and how do we support Golang and Rust and TypeScript, and making sure that we can grab a lot of developers to actually build these verifiable services. So that's been a huge focus of mine since joining.
Hey, I'm Noah. I'm, I guess, the product lead at Layer. And I've been the main consumer of Waves, kind of dogfooding it and testing it and giving feedback to the engineering team, so we can kind of really rapidly iterate and get this stuff built and out there. Jake and I have been working together for over 3 years now on crazy verifiable smart contract based governance stuff and DAOs and blockchain. And I was lucky enough to meet him right when I graduated from college. And then Reece was it's just been around. We've always worked together. So it's cool that we've all come together to do this crazy new thing that is Waves.
Awesome. A-tier stuff. Thank you, gentlemen. Absolute chads. So I just want to take a step back for those who may be joining us for the first time, who may only be familiar with kind of the high level of EigenLayer. Waves is built on EigenLayer. And so you guys are using the core protocol to kind of extend it. Now, I know personally, building AVSs and stuff on EigenLayer has been difficult. We've been kind of flying the plane as we've been building it. We started with the wings, added the engines later. You kind of had to pedal through it. So there's a lot of things that you guys have kind of solved and have done. For those who may be familiar with restaking and slashing on EigenLayer, can we just, maybe what does Waves stand for? What does it do? And then we'll get into, kind of how it works. What are you enabling for developers with Waves? how does it use EigenLayer, and then we'll dig into some of the nitty gritty and talk about the OSS piece as well.
Cool. I'm gonna do a high level pass. Reece might provide a little bit more color. Like Waves stands for WebAssembly Verifiable Services. And it's a runtime. It's a runtime that lets you run programs, decentralized, verifiable programs inside of it. I know this is a little bit complicated for certain people, so we're going to try to explain like we're five. What does EigenLayer do? EigenLayer handles the restaking and the slashing, right? That's where all the crypto economic security comes from, right? That Waves programs can then leverage that crypto economic security. Importantly, EigenLayer is what defines the operator set. So we have a verifiable service, right? That's run by many different operators. EigenLayer and restaked value inside of EigenLayer defines who are those operators that are running that service. EigenLayer enforces who, like, you know, the crypto economic security system for like that whole platform. It's, you know, so that's kind of EigenLayer. Where EigenLayer provides the crypto economic security, that's what determines the operator set, right? And then Waves is this runtime that they're running. Now, WebAssembly, I don't know how many people have heard of WebAssembly before, but it's really cool. Right now, real cloud providers like Amazon and Microsoft are putting hundreds of millions of dollars into WebAssembly as a technology. Why are they doing this? Well, it's because they can save 50x on cloud computes.
Is it really that? Is it really that much more efficient?
Let me break it down for you, okay? So, and then this is relevant for Eigen, right? Because at the end of the day, we're building an economy here. If you're going to build a decentralized cloud, we need to like build like real economics that actually work. So, WebAssembly, like, why is it more efficient than like say a technology like Docker, right? Well, every Docker image has a Linux file system in it. So that means like every time you have some new program, you just got your little Python script, right? And to run that Python program or that Go program or whatever, you have to have a whole Linux operating system in there, which has startup time.
Yeah,
it has startup time, right? It takes like a couple seconds for the Docker image to start up. That's not great because then let's say you have a service that runs once a month, or it's listening for some event that's happening on Ethereum or on Base, right? And that happens like maybe like once a week. It's not a widely used service. Well, we have to have that Docker container just idling the whole time because it has a startup time, right? Like,
right.
You know,
Right.
You know, so it's like you're wasting all these compute resources, right? You can't just like, you know, you're wasting like disk storage, right? You're wasting memory. There's some efficiency overhead, but the real thing is just like you have to have all these programs that are just idling and wasting all these compute resources when they're not needed. So this is actually where WebAssembly comes in. Specifically, this technology called WebAssembly System Interface, which is what Waves is a runtime for. And this allows you to have a bunch of little WASM programs that, like, as soon as we need them, like we can load them from disk in like micron seconds. We can like execute them in micron seconds. So there's no startup time basically. So we can take your same program, instead of throwing it in like a Docker image with a whole Linux operating system, we can actually just like directly execute it, like as fast as we can load it from disk. And if it's a popularly used program, then it's just in memory, it's even faster. So this is really about scaling and making the economics of the decentralized cloud work, right? And even it's a sign that like our current cloud providers, you know, are investing a lot of money into this because it's going to make the economics of the existing cloud work a lot better. And just as like a little factoid, I was watching some of the talks from WasmCon recently, or WasmIO, and someone did some benchmarking around how many like basic cloud functions can you run in Docker images on your MacBook Pro versus like how many WebAssembly components can you run on a MacBook Pro. And it's orders of magnitude of difference. You can run about like 50 like Docker image on like a baseline, you know, M1 MacBook. You can run 20,000 WASM components on that same MacBook Pro.
Interesting.
On that same M1 MacBook, yeah.
All right, so I just want to, can I just pause and ask a few questions there? Because that,
sure, it's a lot, yeah, I know. I
want to make sure people don't miss what you said there. So I guess a few things. One, Docker images are heavy. You're running an entire operating system. Every tiny 100 kilobyte Python program's got its own kernel, its own file system, its own memory allocation. And like you said, those things are heavy. You can only run a certain number of those. And so if you're running on a cloud or you're running decentralized, in which case you're running it multiple times, potentially providing consensus over it, the operator cost on that just doesn't work out. And people are always just going to want to centralize it because that's potentially a cheaper way to do it. And so by running Wasm, you're basically throwing out all of that duplication and loading these tiny compressed like bytecode programs into memory, which reduces the operator cost, which requires either less protocol emissions or less rewards, having to go through the system. More people are going to want to run it. They're going to be more decentralized because of it, because more people are going to want to run it. And then you get increased security because the cost is so low that people can do it. So it's kind of Ethereumizing your Dockers. Did I butcher that?
Yeah, no, I think it's pretty good. Like TLDR, you can run more services on a given unit of compute, right? So your operator is paying for, a box to run, right? And they can run thousands of services on that box versus like running like one service or like a couple services on the box, right? It's like the unit economics of the decentralized cloud.
Right. And then you also said that you support like Rust and Python, and I think you said Solidity and TypeScript. Maybe you can describe for folks like a little bit how that works with Wasm and like what the features are of that, what the limitations might be. For those who aren't familiar with, I guess, is it transpiling? Is that what it's called?
So the beauty of it is within the WASI spec, we have this thing called a WIT file. If you're familiar with interfaces as a programmer, it's just like, what does the structure of this look like from a schema perspective? With this, a bunch of tools built by Bytecode Alliance allows for us to actually automatically compile this into other languages to reuse it. So you can write a component in Rust, then you can import that into a Go component and call into specific functions within that. That's already possible today. It's already within our template. Where it really goes to the next level is us just providing you all of that out of the box. Here's an example in Go, here's an example in Rust, and now you can just continue to build on top of the interfaces. So you're able to mix and match with other people's components in other languages into a language of your choice. Today we have Golang, we've got Rust, we have TypeScript support. We also have Python support that's available for some people. It's difficult with like LLM-based models. That's the main reason people want it. There's some ways that we can like try to work around that, but that's taken a little bit longer than expected. But we're able to mix and match. So you can focus on, your team being a backend team can focus on the Rust end or the Go side. And then the front end team can like import those components into the TypeScript side and continue on from there.
Oh, that's wild. So not only does it all eventually run Wasm, but it's all fully interoperable. So you can it doesn't even matter what language. Okay,
it's beautiful. Yes.
That sounds amazing.
Yeah. It's not even transpiling. It's not even transpiling, like you said. It's actually all of those languages individually compiled to Wasm. So that's just like native execution, and they can all piece together without having to have a language transpilation or a library that's written in every language.
Okay, and so there's no like serialization cost or like any of that going, between the membranes. That is, that's incredible. Because I remember the demos that Jake showed me early on. He had a few different ones, but they weren't kind of hybrid in that fashion. And so that sounds awesome on the tech side. We talked about EigenLayer. We talked about kind of the runtime piece. But then, I think the bigger story here is the developers, right? Like you have to bring those guys in. The operators are definitely going to want to come in and run these things because it's going to be cheap. But there's a developer story here. The first part of the developer story is how easy you've made it. Jake, that was the piece that blew me away. I was like, man, like this is just light years ahead of, the current state of the art back in February. And then we can get to the open source piece and kind of why that's important and kind of dig into why we're here today. But I want to provide the context so people understand all the way up. So let's focus on the developers and kind of what you guys have done for folks in that arena.
Yeah, so building an AVS is hard. You have to build a lot more than just your core application logic. First of all, you have to understand how all the Eigen contracts work. How do you register a service? How do operators like opt into running a service? Like all that kind of stuff, right?
Sorry about that.
It's okay. It's it's complicated stuff, right? And sometimes things are complicated, and it's obviously like we want to make things as easy as possible, but we want to make things as easy as possible while making things actually decentralized and good at the same time. It takes a while. But one of the things I've always liked about Eigen is just having a long-term vision. That's really cool, right? It's like, let's try to do audacious and cool things. So yeah, like I think Waves does a lot to like make it easy, right? Like, which is like all that logic around how do you listen for events from different blockchains? Like, how do I listen for an event from Base, or an event from Arbitrum, or an event from some Avalanche chain, or some random Cosmos chain, or from Solana, right? All that logic, right? Of like, especially if we're dealing with non-EVM things, we have to know about encoding and decoding, right? We have to build reliable logic to listen for RPCs across multiple different chains, right? Like even just listening for triggers, right? Listening for events from various different chains, like DeFi trade or whatever, something you're reacting to with your program. That's a lot of logic, right? It's really complicated. A lot of the baseline like Eigen examples have oftentimes just been like, how do you listen on just one chain as well, right? Like, so doing this in a multi-chain way that's performant, right? How do we listen across like 10 different chains or more, right? How do we listen across different chains with different VMs, right? That's something that Waves provides out of the box, right? Is that capability to like scalably listen from different RPCs from various different chains, right? And seamlessly encode and like decode events, right? Then there's the runtime itself, and the runtime is really cool. It has some features we haven't even talked about, like composability. So you can have components that trigger other components, that trigger custom aggregation flows, that trigger more components. Like you can make these workflows, right? Of like these very complicated, like if this then that, like application logic, like max composability. But really, we try to make it simple. Like, so let's just say you're making like a nice little hello world service. Like you can just do that in one file. You just write your application logic in one file. You have an input and then you have an output, right? The input comes from all our RPC stuff. Like it comes from Base, it comes from Arbitrum, or whatever you set up the trigger to listen to. It might even be an off-chain trigger. The input comes in, right? You do something with that input, your application logic, right? And then you have an output. The output, we take that and we sign it. So we deal, like Waves handles all the cryptographic signing stuff. Do you know about BLS? Do you know about BLS signatures? Do you know about ECDSA? You don't have to, like that stuff's complicated, right? A lot of crypto developers like really have to spend a lot of time like understanding that. And I recommend crypto developers spend time understanding that. But if you're just trying to build an application, right? That's a lot of overhead, a lot of things you have to understand in order to build your application. So like Waves can like extract that away for you. You really have to think input, output. Like anyone can just vibe code that. Right? Like,
yeah. But like when you write a smart contract, you're not thinking about how to accept a transaction, how to verify the signatures, how to write state to a blockchain. You just like set your variables. You define your function handler for the execution. It should be the exact same thing. It's just like, here's the trigger I want. It's in the config. Waves knows what trigger I want. And then I spin up with exactly the trigger data that I asked for.
Interesting. Okay. So developers don't have to worry about doing any of the signatures. They don't have to worry about the consensus piece. They don't have to worry about like gathering any of the inputs. Question on the input. So you talked a lot about like getting cross-chain data. Just I guess out of my morbid curiosity, do these execution environments have these sort of built in, or am I like providing my own RPC URLs, and like how does, I don't know, maybe I'm getting off the beaten path here, but that just jumped out to me as like.
Yeah, I think that like we're probably going to launch a first sell for AVS like experience on top of Eigen that will give you like all the RPCs and stuff from common chains you want. Like, if you're just like building with Waves purely open source though, as an AVS provider, you're going to have to work with your operators to like, get them to like either use reliable RPC providers, or if let's say you're building something that's like hypersensitive, you might have a requirement on your operators that, hey, you have to run a full node for each every chain in this network, right? It's going to depend on the AVS service. So
okay.
Obviously,
you could like set flags like that. Like I need my operators to have these like specs or whatever, and it could only run on those operators. Or The operator can just like choose a reliable RVC, and if you trust them, you don't need to mess with that yourself also. So it's
Sure.
kind of anything is possible.
And so you found like a lot of these common problems that anybody building a verifiable app is going to need, and you sort of anticipated them and provided the bindings and the environments and sort of the pre-built components. So they're not just like, all right, here's a raw TypeScript environment, like figure it out, boss. Like import your dependencies. Like, oh, here's the first 5 things I'm already going to need, and they're already right here, and I don't have to reinvent the wheel.
Yeah.
Awesome.
And we go even crazier, because I think that the real reason developers want to build with Waves is you want to build with like the most powerful stack that you can. Like, how do you do like the factory pattern? You know about the factory pattern in smart contracts? Like you have a smart contract that creates another smart contract. How do you do that with verifiable services? No one's even wrapped their brains around that, but we already have that working.
Hold on.
So you want to make your permissionless prediction market, right? Where it's like someone just goes in and clicks a button and like it automatically spins up a verifiable service. Well, you're going to want to do that in Waves, right? Because everyone's just shipping like their AVSs, like these big monolithic, like Docker, that's fine, right? There's a time where you're going to want that as an AVS, right? Like, but if you're building something that's like going to follow a factory pattern, where you're not just going to have one service, you're going to have like potentially like thousands of services. That is a perfect fit for Waves. So anything like you want to make permissionless prediction markets, like things like that, where you have like the ability for people to come in and like easily create like new types of services.
So hold up.
Choose Waves for that.
Hold up. You have a demo somewhere where you have an AVS or a verifiable service running on Waves that prints AVSs.
Yes.
Dude, that's incredible. Because then it's like create 2 for entire apps using Waves, and then it's on Waves, and then you can get the references, and they just like infinitely compose themselves. Is that where I'm getting at?
Yeah.
Okay.
Like,
all right.
I think
episode 2 demo land on that. That's I'm like wrapping my head around that quite a bit. I am compelled to ask you how that works, but we don't have enough time to cover it. So
we don't have enough time. Yeah.
I'm gonna fight the instinct to dig there, and we're just gonna move on. But
sometimes we just have to throw in like little teasers, like ICO, secret demo somewhere on base mainnet. Try to find it. Factory pattern.
Yeah.
Like but we need to talk about other things.
Very cool. All right. So the big announcement for you guys is that this entire thing that we've just discussed is open source now in some fashion. And so what portions are open source? What portions aren't, if there are any? What does it mean for you guys to make this open source? Why not earlier? Why now? What are the advantages for it? What do you want people to know about this move?
Yeah, well, I don't think we can have verifiable apps or verifiable services unless we can actually really inspect the code that runs them. Crazy idea. This is OG blockchain stuff, right? Like one of the tenets of this industry, and some people have forgotten in the wake of like all these like, less cypherpunk, kind of people, and chains and projects, whatever. I'm not going to call them out, but like we all know who they are. Like open source is one of the core tenets of this industry that made it like possible to begin with, right? And that's what I think true verifiability is. Like if something's a black box and you can't look at how it works, how do you know it's verifiable? How do you know there's not some secret backdoor, right? It's like, how do you know they don't have some edge case in like that's going to get them around whatever slashing criteria or whatever? Like, how can you really trust it? Like, I think that verifiability and open source kind of go hand in hand. Like if you can't like take it apart and see how it works, like it's not, it's just the marketing then, right?
I mean, it's like DAOs. Like there's no reason to trust a DAO unless you can read the software that the DAO is running. Because why would you trust that we wrote DAO software that doesn't just give us access to your treasury?
Right.
In theory, that's illegal, but like, why would you trust this like on-chain super crazy? Like, you can look at the hash and maybe like you can compare the hash with the hash that the team told you they're running, and what does that mean unless you trust the people that made it? But you don't have to trust the people that made it if you can read the code and then compile it and then check the hash. So you don't want to trust us. We don't want you to have to trust us.
Right. And so the components that are open source, like maybe just going in a one layer deeper, or at least it's one layer to me. Are there multiple repos? Like, is layer running as its own AVS? Are there backend components that are being here? Like you want to be able to see the code, but you also need to like know how
we have some templates, right? Like that's normally what projects open source. Like here's a template, here's how you can build on top of our thing, right? So obviously we have those, right? You can go to the Layer Labs, GitHub repo. Maybe someone will link.
We've had those for months, almost a year, I think.
But no, this is actually the entire Waves runtime. The entire Waves runtime. Everything you need to like build your fully sovereign AVS and like completely like cut us out of everything and fuck us over. Like it's all open source. Why? Because I think that like I would like to see like a real developer ecosystem built up around WebAssembly technologies. I think that like we need to move past just like the marketing. Like I actually want to see a world with verifiable applications. Like I actually really do. And we really need to accelerate that world because like AI is going to take everybody's job soon. And it's like, if we don't build alternatives and not just like market them, like, I mean, actually fucking build them. Like everyone's talking about verifiable AI, but I've like seen like hardly any fucking verifiable AI applications, right? It's just like, it's all just like fucking mouth words, right? So it's like, I think,
I can dig it.
And look, we built this stuff. So like, we didn't build it to just build like boring fucking infrastructure. No, we're actually just like secretly gonna just build apps. Like, and we have like amazing, we do have like a library of like a lot of our own really cool components, and we're going to open source a lot of them, but we need some secret sauce. So the runtime is completely open source. There's a lot of examples for how to use it. We have a bunch of extra examples ourselves. If you're a team that, wants to like move a lot faster and, align economic incentives with us, we'll work with you and help you out a lot and help you accomplish your vision. Like, but yeah, the whole thing's open source.
Wow. So like all of Layer, everything that you guys have been building for probably over a year now is on GitHub, and they can just go.
Yeah. I mean, the Waves runtime is there. You have your choice between EigenLayer middleware and proof of governance or proof of authority middleware. If you want to just have like, here's a verifiable service and these operators just run it. Yeah, it's all there. We got examples. We're happy to talk with teams. Obviously, like if teams like want to align economic incentives together, we'll spend more time talking with you and helping you. We do have some like secret applications that we've been building with like a lot of really useful components and things like the factory pattern and stuff in them. Those will be open source in due time, but we open source those strategically when we can like capture like value around those things. And we do have like some really I've said for a long time that Layer has just like kind of been a front, and that like really we were building like this like kind of like other thing that we don't talk about unless you're in the secret society.
Fight Club, yeah.
It's like
the Layer liquid. That's where we're going with this.
Yeah, well, Layer's always it's always been a dumb name. Like it's just a joke. It's a joke that went too far. Like, there's too many layers. Like it's so boring, so vanilla.
Gotta put your weight on the top of your layer.
Yeah.
Back to the question real quick, unless you have something more to say, Jake.
No, I think I need to shut up for a second.
You said secret society 1 out of 1 times. There's no more times you can say that. There are like other things that are not open source yet that will be soon, that are like emergent libraries that will be really useful, like Reece was talking about with the WIT files and these like common interfaces. Like we think like IPFS will be a useful thing, like if you want to store like a Merkle tree distributing tokens or something on IPFS and then distribute them on chain. We'll have like an IPFS package that you can just kind of import and use in your component. So things like that. They're currently private because they're just like not fully refined, the interfaces, and they're not totally tested, but we have been using them in our other like secret apps. So those will kind of come out as the ecosystem is growing and as we have like battle tested them so that they're ready to use. So things like tools and different things around the core infrastructure that make it easier to use will keep coming out.
I also heard a rumor It might be substantiated actually. I heard a rumor that people get very sizable points for like contributions to open source, especially open source like Waves repos or
I heard
Waves
that too.
example repo.
I did hear that.
I think it's substantiated. So
Interesting. For those sitting in the back of the class, you might want to rewind and take a look at that. So contributing to open source has always been a very positive thing to do. And now that, Waves is open source and we can collaborate and build factories and all this stuff together, it seems like we should all be doing that. Very cool.
Sounds great.
Might as well.
Might as well. Seems like a good idea to me. Excellent. And so then, you guys have been marching towards this. Jake, I remember you telling me that you were going to open source it like back in February. I didn't believe you, but here we are. So how have you guys been like preparing for that? Like, what have you been cooking up? Like, what was your process? What was your dog fooding? Like, maybe you can just tell a little bit about the road to this moment for you guys.
It's been a long time. We definitely did made a lot of demos, some of which that we released and like didn't even market, which was like really unfortunate. We had this really cool Waves art demo with like fully decentralized, running on whole sky testnet, like generative AI art NFTs, running like deterministic, like stable diffusion and LLM inferencing and all this stuff. And we just never marketed it, which is a big fail. Layer marketing is notoriously like terrible, but we've also been like building an app, which is actually like currently live on Base, but you have to be like, it's very underground, invite only. And I've told that the layer marketing team will be fired if they like talk about it. But maybe if you meet me in person at some random conference, I'll send you an invite.
Okay. We got to think.
That's actually been really like it's always best to like just like test and prod, right? And like test and prod with like a small group of people.
This week has been a lot of testing and prod. It's been informative.
To make sure that the wheels don't fall off. So it's like, yeah, we're live on mainnet.
Awesome. All right. Lots of dog fooding action. I got to figure out like what Berlin Underground nightclub I got to meet you at to get it on this Base app. So
you know the one. You know the one. Just tell me where to fly.
That's so. And then this is all GPL v3, right? Or is this BSL? What are we doing?
So I think we decided, we're just a small startup. We don't have like hundreds of millions of dollars from like A16Z, and we want to make sure that like if we're going to open source Waves, it's kind of like nice public good style. We do have a contributor license agreement. So if you contribute to Waves, you're gonna have to sign the CLA, and we might re-license it to a more open license like MIT in the future. But at this phase, like we want to just make sure and honestly, if a team is using Waves and not providing any financial value to us, but actually like contributing to the software, great. That's amazing. You're paying your way, right?
Right.
So like if people are using Waves but like contributing to like the open source ecosystem around it, that's super valuable for everybody. It might change in the future. We might go with a more like open license, but I think for the current state where Waves is at, the GPL license is great. And I will note that if you that's just the Waves runtime. If you build other like WebAssembly component or applications on top of Waves, those can be licensed however you want. You could even make them proprietary if you wanted to.
Right. I mean, from an ethos perspective, it makes sense, right? You guys spend all this time building, Waves, which sounds incredible. I think everybody should check it out. And then you just want to make sure that if people are working on it, that all the value goes to kind of one spot, so everybody can continue to benefit from it.
Totally.
Right? That makes
if one team adds like move support, we should all benefit from it. It's like, I mean, we'll add move support eventually, but like
and that's like the cyberpunk thing, like, it's free, keep it all in the same spot. So I feel that's very congruent with the mission and where you guys are at right now.
I think it's good for where we're at right now. I think we'll see like, where things go in the future, but
so taking a look at the agenda here.
One more important thing to note on license, all our other tools and stuff are all like MIT. So like
Oh, right, okay.
the templates, the examples, those are all MIT. So
And then you can just do whatever you want with those.
then you can just do whatever you want with those.
That
I think
that
that was important to mention. So
so I think you've already done a really good job of kind of talking about some of the benefits of waves. You get on-chain, off-chain composability. You can do multi-chain stuff because of the execution speed and load and the amount of like overhead that it's like very scalable. And then you kind of just dropped a teaser with some of the composability stuff that I am very interested in. Dynamic programming has always been, one of my most favorite topics, and one of the few reasons I respect Ruby. One of the few reasons I respect Ruby as a language. And there's like infinite stuff there. What kind of like apps would you expect kind of like the first wave of developers to want to build on top of Waves? And like, what's their like 3-day journey look like? So if somebody's watching this now and they're a developer and they're thinking, oh, it's going to be easy to build on top of Waves and EigenLayer, like what are the keywords or types of apps you would want them to start fiddling with? And then, if they go and they download the repo, like what is their, first 6 hours going to look like?
Reece, do you want to take the first 6 hours part, but I'll take the apps part.
Yeah, in the first 6 hours, you're going to be able to easily get something launched with our price oracle. So it's a very basic component, multiple different languages, and it just queries out to CoinGecko, hey, here's a price that a user requests. So we already have the solidity done for you. So you can get started with something that is already making HTTP requests like right away within components. From there, you can modify it. And one thing that I'm excited about.
That's like 20 minutes, not 6 hours, to be fair.
Yes, that's like very quick. Like it's mostly just going to be you playing around with it. You can get launched if your system is like reasonably configured, like you're normally a developer. You can get reasonably launched within about 20 minutes, probably within about 10. Honestly, like including installing, missing dependencies and things like that you need on your like Ubuntu system. We support Windows via WSL. We support Mac OS as well as like standard Linux with most distros there. So like we give you all of that within the main README. We're constantly testing that. We've written like custom testing to like make sure that we run this in runner. So like all the documentation is always up to date. So like that's our key focus, is making sure the devs, like you have the documentation, it's there, it works, we've verified that it works. From there, you just go and start implementing your application idea on top of what we've already given you within the template. One thing I'm excited about is like RWAs, like doing stocks on chain. Like Waves makes that super simple. You see someone do a buy order, you submit that to the aggregator component, which you can continue to write. That can go make a request on some other API, return back, and then now mint the user tokens. Like this flow is maybe a couple hundred lines of code in a Waves component, which is drastically different from entire platforms that have had to be built up over the past couple of months to like launch this. Like, no, you could go spin this up with a solo dev in the course of a weekend and have an RWA based platform with some niche, stocks or some other commodities that you want. Like that's entirely possible. And I actually built that up within, a weekend one time, like very early days Waves. Now it's even simpler to do with all of the tooling and stuff we've built up for developers. So that's a big one, RWAs.
I think No, go for it.
Sorry, I just wanted to make one snarky comment.
Yeah.
You went out of your way to support Windows developers?
Absolutely. We want to capture the entire market. We're going for TypeScript, Python. We're going for all of those. So you have to capture all of the market of developers. That means you have to go through all of the tools that they use. Whether I have my own WSL machine, I know, I hate it, it's terrible, but I will do it for the developers because that's what the experience requires.
Whoever did the Windows support did God's work. Like
appreciate it.
A second laptop.
Reece is a legend.
Yes, I have done some pain in Cosmos and then now an EVM on WSL. It works. We have one of our devs full-time on WSL as well, testing it constantly. We're really stress testing it, making sure it's the best for all devs.
Buy that guy a back massage because my goodness. Okay,
for sure.
Sorry, no, I didn't want to.
All good. No, you had to say it.
And I just like get out of town. There's no way.
Yeah, we should cancel Windows.
Jake never wanted to be too outspoken.
No, Jake's subtle. That's what we love about him. No, I mean, like something else that's surprisingly easy to build is like a point system. I don't know why anyone would need that, but a point system that has this like deterministic verifiable Merkle tree generator that you can just like start listening for events on anyone's contract. So maybe you like different projects and you want to like get those people involved in your project. You might want to like start just pick different like events that they emit in their contract. You didn't even write this contract. You just check their code. You saw they emit like did a thing, and then you check the sender address. You could just like plug 5 different people's contracts into your component, generate a Merkle tree, throw it on IPFS, and then commit that root on chain to a distribute like the universal distributed contract from Morpho. And then you instantly have this like verifiable decentralized distribution mechanism. And it's like maybe 50 lines or something.
So
that could take you an hour.
You could even monitor a factory contract, see what contracts came out of that, see who interacted with those contracts, and give them points.
Yep.
And then you could even monitor, since it's off chain, you could even monitor like GitHub commits and PRs and give them.
You definitely could. We may or may not have done that or plan to do that. But yeah, you could combine those both as input streams into the same Merkle tree. And every time one of them happens, you also just check all the other ones.
Yeah, it's almost like verifiable services let you build like next gen incentive systems and like next gen governance systems.
Not that we have use for that. Not that
we're not doing anything with that.
I don't know why someone. Yeah.
Okay.
We're just
throwing out random ideas, guys.
I don't think you should follow the at Wabs Twitter account. You should definitely not follow it. It's for devs only.
Wabs. Don't follow that account.
Don't follow it.
Wabs. Spelled as it sounds.
_ Wabs.
Okay.
Pronounced waves, but look like Wabs.
No, it's pronounced Wabs.
It's pronounced.
All right, it's pronounced Wabs. Heard it here first, I guess.
I'm definitely not following them right now. So with that, Jake, you want to talk a little bit about some of the other apps? I know you wanted to get to that.
Wait, one more before Jake talks.
Go ahead. Yeah. Sounds great.
To build that incentive system that no one's going to use, you might need like an indexer to like index on-chain events, and you might want to do that multi-chain. So you could like have apps on Ethereum, apps in the Cosmos, apps on Solana, apps on Base, and you need to record the fact that all these events have happened in order to like regenerate the Merkle tree and have like a history to prove why the Merkle tree is the way it is for the points distribution. So you could do this. No one's ever done this before, definitely not us this week, but you could do this. We listen to all these different contracts and all these different chains, and then have an indexer that's actually an on-chain indexer that's indexing other events on chain, and then your component just queries your indexer and then builds a Merkle tree from it. So you can make an indexer on chain using waves as the listener, and then a really cheap storage layer like Base as the storage layer, and it costs less than a cent to add a new indexing event. And so now you don't even need Postgres, you don't need a centralized off-chain server, you don't need AWS. You could just index on-chain events on chain, and then use waves to ask for that information and then display it on a website or whatever.
What was that? I'm trying to remember the name of it. There was that indexing chain. What was it called? Was it Open Graph? I can't remember.
Graph.
The graph. Oh yeah, graph. That's right. Yeah.
It was like layer. They were like, we're just gonna be graph. And
no, I remember that. That was that 2020 or 2019.
They had some really good parties back in the day.
Yeah. I was just thinking, you basically just described that you could do on waves, very simply, especially with the help of the Base and the storage kind of
throw it on L3. There's all this like amazing storage out there. There's all these EVM chains that are just like, please use us, and they're like, it's like basically free.
Oh man!
Then the next level is then you introduce like a bribe market on top, where then people can like direct this activity. Oh wait, I'm saying too much. Fuck.
We call it a fee market. Call it a fee market. Jake, you're gonna be so much fun at parties. I swear to God.
I'm the most. We have the best parties in crypto, but you never hear about them because it's all super underground. I'm very consistent. Like we have the most boring, like
Your marketing team is the highest paid for the least work. That's all I'm hearing. This is great.
I love our marketing team.
Marketing team. Yeah, there you go. Awesome. So we talked oracles, but there was some other ones here. You talked dynamic incentive systems, multi-chain applications, real world integration. There's so much. We could sit here.
Well, we're actually doing a really cool one with Gitcoin really soon. A small experiment for like the next Gitcoin grant round, and it's called Trust Graph. So one of the things that you can do with verifiable services that you could never do before is you could take like a graph of like attestations, like people vouching for each other and stuff like that. You could decide like, okay, these people are in like our kind of core authoritative seed, right? And then you can do PageRank style calculations on what their voting power should be. So we're doing that for next, like there's more to come. There's a whole paper.
If you don't know what PageRank is, it's like how search engines index the web, where they like track the number of links that go between different websites, and then they can give you a trust score based on how many people link to you. And the links that you give to other people are not valuable if you don't get a lot of links. So you can't just spam your way into having a lot of authority.
It's like verifiable meritocracy.
Yeah. Web of trust style. Throwing it back. Yeah.
But you couldn't do those types of graph calculations in Solidity alone, right? Like you need verifiable services to make these things. It's like, we have a whole paper on next gen governance systems that's coming out very shortly. So it's an exciting time to be building verifiable services. If you're a developer and you're interested in these things, you've chosen the right field. This is a great area. Hardly anyone understands what a verifiable service is. Hell, like we haven't seen that many examples that are like super original and cool, but that's changing. It's like, this is a very exciting field to get into. So
that is awesome, Jake. You have me super excited. I think we're gonna start wrapping things up. A couple things. If you haven't followed them already, Layer on ETH is their X. Also their WAVs_WAVs account is definitely something you are not going to want to follow, is I believe what I was told. They're also WAVs.xyz. And you can find their GitHub is now that's not something you're unlocking like in an hour or 2 hours from now. Like
it's already unlocked. Yeah. We just go to WAVS.xyz and the links to our GitHub and stuff is all there. So you can find it.
Boom. Awesome. Jake, Reece, Noah, I'll give you guys the floor. Anything else you want to say with the platform we have right here? And then we'll log out and see everybody in the comments.
Reece, Noah?
We're excited to see devs using this, including our Windows users, whether or not we may agree. Using it, building it up, we got to build the next gen AVSs. Let's go for it.
Let's go. Anything else, gentlemen?
I think that I'm not sure if I'm allowed to say this, but I'm going to say it anyway. I think a number of types of behaviors are soon about to be incentivized. So I'll let people guess which ones. And I will say there's going to be, at some point, the secret's going to be out. And there's going to be this crazy DAO game hive mind experiment. And you might want to partake in it.
Great. Well, there's Jake not telling us anything for over an hour.
Great. Scott, crypto is all about the announcement of the announcement. And you have to give us a little bit of like the announcement of the announcement.
Dude, you are the master of announcements. We are here for it.
I don't know. I mean, look at how many Twitter followers Layer has. We're not doing so hot. So,
well, where are you at? Let's see here.
It's like we got like 6,000 something. I don't know. Such boring. You don't want to follow Layer. You want to follow WAVs.
Yeah. We've been heads down building for over a year. It's time. We're excited. The engineering team is very excited to finally be building for people and launching it. Like the motivation the past month has been higher than it's been the whole time. So
I'm just happy to build apps again. I feel you probably feel the same way. It's like nice to like actually build apps. Like building infra is just so boring. So necessary, but it's
you got to do it to unblock yourself, but you can't do it too long or else you lose the plot.
Yeah, for sure. The thing I like about building apps is just the dev cycle, right? You build a feature, you see it work.
Yeah.
You build the feature, you see it
You
work.
talk to people about it too. Like you get that community feedback when you're building infra. You don't really get that.
That's so very true. So I'm excited to build on Layer. I'm excited to commit to your open source repos. I'm excited to get into underground Berlin clubs up in here. So Jake, Reece, Noah, thank you so much for the last hour. These guys dropped a lot of alpha. So if you haven't paid attention, go pay attention. This stuff is cool. What they're doing is great. The open source license, congratulations, gentlemen, on all of the hard work. Follow these dudes on Twitter, download their software, and get hacking. We'll see you guys in the comments section. Thanks for coming.
Thanks,
Thanks,
Scott.
Scott.
Appreciate it.
Bye.
Peace.
Have a good one. Do we all leave now?